Hi, everyone, and welcome to Feed and Grain Chat. I'm your host, Elise Schaefer, editor of Feed and Grain. This edition of Feed and Grain Chat is brought to you by Watt Global Media and feedandgrain.com. Feedandgrain.com is your source for the latest news, product, and equipment information for the grain handling and feed manufacturing industries. Today, I'm joined by Carl Swisher, Sales Manager, Material Handling Division for 4B Components Limited. He's here with his advice on how to plan for increasing bucket elevator capacity in grain and feed facilities. Hi, Carl. Thanks for joining me today.
Well, good morning.
Well, can you start by sharing how bucket elevator design and technology has evolved over the past few years?
Not just the past few years, but let's just talk about the past few decades. So, back in the 60s and the 70s and the early 80s, when equipment was designed, manufactured, and delivered, it tended to be very much overbuilt for the application. There was additional horsepower, there was additional shaft diameters, there was additional casing thickness, and that lended itself to making modifications down the road much more easy. But nowadays, in the recent decades, in the 90s and 2000s, in order to be more competitive on price and be more efficient with materials, equipment has been made closer to the tolerances. And the horsepower is exactly what's needed to deliver the offered or the promoted bushels per hour, the same with shaft diameters and casing thickness. When you go to make modifications to a bucket elevator, sometimes the heritage or the legacy or the manufacture date can drive some of the issues you need to look for.
When a facility decides to increase bucket elevator capacity, what are the pitfalls of simply increasing speed or adding buckets, and how should they approach it?
Bucket elevators in specific are designed around the laws of physics, especially centrifugal discharge, where the buckets are moving over the head pulley and centrifugal force is pulling the product out of the bucket. So it's an equation based on pulley diameter, bucket size, and speed, and the commodity itself. And all of these variables go into the equation to make an efficient discharge. Now, once you start manipulating one of those variables, everything else can become unbalanced in the equation. So simply increasing speed can have a lot of consequences because it's disrupting the laws of physics as it relates to all the other variables that are involved. Very often, if you just increase speed, the product doesn't have enough time to get in or out of the bucket, which can lend itself to downlegging, material missing the outlet and coming back down the down leg. Sometimes if they're going too fast, the bucket will release the product too soon, and then it will fall down the up leg. A careful thought needs to be put into how much faster, if at all, you can go, how much closer together you can put the buckets based on the laws of physics.
So, what about the role of other key components like buckets and belt material? How do these impact efficiency or performance when designing a capacity upgrade?
That's a good question. Very often, if you're going to increase the capacity by adding bushels per hour, you're increasing the weight and the drag on the entire system. So very often you need to go from the certain belt tension up to a greater belt tension. For example, some numbers would be like a belt that has 330 pounds per inch width belt tension. You're going to have to go and increase that to a more robust elevator belt, maybe one with 440 pounds per inch width or more. And the same with the buckets. The most common plastic that's used is high-density polyethylene, and that's great. It's a very cost-effective general-purpose plastic that performs well in the grain and feed industry. But if you're increasing capacity or you decide to feed your bucket elevator on the down leg, then you might want to upgrade to a more robust plastic, one that's more durable or abrasion resistant, such as a nylon or urethane, especially if it's going to be doing a little bit more digging in the boot.
How does the grain's handling characteristics impact bucket elevator performance? And what modifications do you recommend for high moisture grain or other specific characteristics?
That's another very good question. And there's a considerable difference between the characteristics of wet whole grains and dry whole grains. And most equipment, when it's specified in the manufacturer's literature, is based around dry, free-flowing grain. However, very often the material is going to be a wet grain as it's coming out of the truck that's bringing it in, or it's going into the dryer at the facility. Wet grain and ground grain tend to be much more sluggish. They don't move as freely. And so you want to space the elevator buckets further apart so that sluggish material has time to get in and out of the bucket. But also the speed sometimes needs to be slowed down also to give the more sluggish material time to get in and out of the bucket. So yeah, the moisture content, or what you believe the moisture content is going to be, is a big consideration in designing a leg upgrade, or whether you're going to go with low profile buckets, or how you're going to manipulate the speed.
Well, Carl, thank you so much for sharing your insights with us today.
Well, you're very welcome. I appreciate you including me in your podcast.
Of course. Well, that's all for today's Feed and Grain Chat. If you'd like to see more videos like this, subscribe to our YouTube channel, sign up for the Industry Watch Daily e-newsletter, or go to feedandgrain.com and search for videos. Thank you again for watching, and we hope to see you next time.